Hey, Eli.
Hi.
How are you today?
Good.
Good. Would you like me to start with the homework sheet or with the notation stuff? Because like we had, I'm sorry?
It doesn't matter.
Oh, okay. Hey, Sophia. Hey, Kinsley. Who else is here?
Kirsten.
Hey, Kirsten.
Hi.
How are you?
Good.
Does anybody have a preference where you would like me to start?
On the homework we were doing yesterday in class, I did not get number 7 or 8 right.
Okay, so let me just, okay, everybody's good on the ways to represent relations. Is that correct?
Yes. Yes.
Is there anybody who wants me to go over that? I don't want to skip that if somebody's interested. And then we had Unit 3, relations and functions. And then we had this worksheet. How did you guys do on this, the 10 problem worksheet? Anybody want me to go over any of that? I can always go back to that. If it seems to be that there's more questions on this worksheet, is that correct?
Yes.
The function notation? Okay, well, I'll start here and then go back. But Sophia, you had a specific question on number 7. Is that correct?
7 and 8.
Okay.
I did all of number 7.
Well, I'll start with number 7, and if anybody else has a question, y'all can just let me know what they are. And the other thing, if you, I'm trying to make this a little bigger because I know my writing is always a little sketchy. If you have a question, you can either let me know, Ms. Sparks, will you go back and do a certain one, or if you want to type it in the text bar, I'll go back and check that as well. Okay, for number 7. So what we're going to do here is they're asking us to find the function at the value of -5. So we'll plug in -5. And we're going to square it because that's x squared. But we're going to, everywhere there's an x, we'll plug in the value of -5. And then so -5 squared is 50, or it's 25, I'm sorry. And then 25 times 2 is 50. I was jumping ahead of myself. Excuse me just a minute. As soon as you all leave, she thinks I'm talking to her, so she starts. Yes. I'm sorry. I have a dog that likes to talk to me while I'm doing math lab. So my daughter was asking me what to do with her because she was leaving the room. Yeah, she thinks I'm talking to her, so she likes to talk. So 50. So I have 4 times a -5, which is -20. So 50 plus a -20 is 30. Minus 9. So that equals 21.
Wait. I did it wrong because I did 2 times 5.
Oh, okay.
So why would you?
I got you. Say that again?
Like 2
you were
times
breaking up a little bit.
5.
Okay, so what you have to do is remember, good questions. These are all great questions because this can be a little confusing when plugging in values, and you're going to be doing a lot of this in quadratics. So I appreciate you asking such detailed questions. What you want to do is just remember in PEMDAS, after you plug in that value for the x, you're going to apply the PEMDAS rules to it once it's all plugged in, and we have to handle exponents first. and then we go into multiplication. So in this particular case, -5 squared is 25, which I didn't write that step out. So I apologize for that, because that might have made it a little easier to understand or follow had I done that. 2 times 25, and then that would be 50 minus 20, which is 30 minus 9. Does that make sense? So the first thing you do is the exponents. The second thing you do is multiplication, and then you do your addition and subtraction. Does that help?
Yes. Yes.
Okay, cool. Great questions. Great questions. I think I'm just going to keep moving forward from there, unless anybody, if that's okay with everybody. And then if you guys want me to go back, you know, to some of the previous ones, I can. But I felt like a lot of you got some of these done in class while I was there, but I don't mind going back. Like if you've already completed one and you still don't understand what we did in class, I will absolutely go back. But let's see. Number 8. This is an absolute value. And just to review the meaning of absolute value, remember anything inside these absolute value bars right here. Let's say I had the absolute value of -2. Because it's actually the measurement that a number is on a number line. It's the measurement of how far it is from 0. So this problem right here is an absolute value. So what you're going to want to do is plug in your -7 inside the absolute value sign. So I've got 7 minus -7 squared, and it's all in those absolute value signs. So that's going to be 7 minus, and then that's going to be 49. Oh, and that's a -7 here. My apologies. So -7 minus 49 is going to give me a -56. And the absolute value of -56 is 56. So G of 7 is 56. That looks weird. That's not what y'all's looks like, is it? That's only part of it. Where's mine? Oh, I know. Better.
I can't see anything.
Okay. I'm trying to make it where you can see it, but it won't disappear, because sometimes when I make it bigger, it's obviously completely disappearing. So I don't know what's going on with it. Hold on. Can y'all see it now?
Yes, ma'am. Yes, ma'am.
Oh, Amanda can't see anything still. I don't know what's going on with that, Amanda. Well, Amanda, we may actually have to take your device to Mr. Cunningham tomorrow.
Okay.
I feel so bad about that. I don't know what to do.
I can send her a picture of my homework.
Oh, that's so sweet. Thank you very much. Because she probably wants to check, to check it. That would be awesome. I wonder what would happen if I sent her Amanda, can you hear me, but you just can't see anything?
I can hear you. I just can't see your work or anything.
Okay. Well, I wonder what would happen if I sent the YouTube video to you later of the math lab.
We can try that.
If you would be able to see that. Well, let's have Mr. Cunningham look at your computer tomorrow, but let's for sure, I'm going to try and send you the link to the recorded one and see if you can see it.
Okay.
Just to make sure, so we can cover all our bases and see why maybe it's not working for you.
Okay, thank you.
Yeah, I'm sorry, sweetheart. I hate that. That's so frustrating. Can everybody else see the worksheet?
Yes, ma'am.
Okay. All right. So number 9 and 10, those were a little bit different because you're actually, the point that it's trying to make is that you can actually solve a function for any value, even if it's another variable. So that's what 9 and 10 are covering. So, and I know I did these in class, but I'm going to go ahead and talk about it again. But basically what it's asking us to do is to plug in the value of c plus 7 anywhere where there's an x. So because I write so big, I'm going to start over here. So f of x, or f of c plus 7, or the function defined at the value c plus 7 would look like this. So I'm going to distribute just like I've always done. I'm going to distribute that 4 to both the c and the 7. So 4c plus 28 plus 11. So sorry, I'm going down into this other box here, but 4c, I'm going to combine like terms. So that gives me 39. So my final answer is 4c plus 39 for number 9. And that's, you can't go any further because you can't combine any more terms or anything like that. So basically, no matter what it says, well, all you're doing with that value is plugging in the actual value. So the answer was 4c plus 39. For number 10, they're asking you to plug in the value of 2k minus 5 anywhere there's an x. So just because I write so big, -9 minus, and then I'm going to put 2k minus 5. And the reason why I want to keep it in parentheses, because there's a minus before the x, that's almost like thinking that there's a -1 out front. So I would have to distribute that -1 to everything inside the parentheses. So once I do that, I've got -1 times 2k, which is going to give me -2k. But on the 5, I've got -1 times a -5, so that's going to be +5. So combining like terms, I have a -9 and a +5. So that's going to give me -2k minus 4 as my final answer for number 10.
Where did the 9 go in that problem?
It got combined with that 5. Did you want me to see it again?
Oh, okay. Yes.
Are you okay? Or you need me to do it again?
No, I understand now.
Okay. Good question, though. Stop me anywhere you guys have a question. I'm really proud of all the great questions that you all are asking. On questions 11 through 16, you're supposed to use the functions to the left to help you solve each of the problems. So I don't know if any of you had an opportunity to watch the Ed puzzle that I shared. It wasn't necessarily mandatory, but it definitely was helpful in the fact that it talks about basically the notation is so that you're naming functions so that when you're working with multiple equations, you can identify which ones they are. So we're actually working with 3 different equations here, f of x, g of x, and h of x. And so each one kind of has its own name. So for number 11, it's asking us for the function f of x, which is the actual function 8 minus 3x, what is the value of that function if 4 were to be plugged in? So that's what it's asking. This is asking for a value. So what that would mean is right here we would have 8 minus 3 times 4 because I'm using this function, okay, plus 9. I'm using that function. So this whole thing right here is just a shortcut way of writing what is the value of this function defined at 4. So this is 8 minus 12, which is 4, plus 9. Actually, it's negative 4 because it's 8 minus 12. My apologies. So that's going to be 5. Because it was 8 minus 12. Does that make sense?
Yeah.
Okay. So let's take a look at number 12. It's asking us, what is the value of g of x at negative 5? And once you find that value, multiply it by negative 2. So negative 2 times, and I'm going to do a big parentheses here, negative 5 squared plus 2 times negative 5. Negative 5 squared is 25. And then 2 times negative 5 is negative 10. So I've got negative 2 times 25 minus 10 is 15. And negative 2 times 15 is negative 30. So the answer to number 12 is negative 30. Are you all following this okay?
Why did you subtract by 30?
I'm sorry?
Why did you subtract by 30?
That's the answer is negative 30.
Oh,
Did you see that all the way down? You want me to redo it?
you're good.
Okay. The final answer is negative 30. Because it was 2, it's negative 2 times 15. So it was this, the result of G at negative 5, the result of this right here, once I plug that negative 5 in, the final value of that was, it was negative 2 times 15. Because that's G of negative 5. G of negative 5 equals 15. So 2 times 15, negative 2. Okay. All right. So now, for 13, we're supposed to find the value of G at 4 and the value of G at negative 1. So G of 4, we'll just do 4 squared plus 2 times 4. That's going to be 16 plus 8. So that's going to be 24. So 24 plus, I don't have enough room in my little box to do all my side work there. If y'all need to attach, I would totally have to have an extra sheet of paper for this assignment. There's a lot of side work. So then I'm going to plug in that -1. So -1 squared plus 2 times a -1. -1 squared is 1. 2 times a -1.
I waited 20 minutes.
Minus 2, because 2 times a -1 is a -2. So that's -1.
What's in parentheses next to the 2?
Oh, yeah, it's kind of ugly, isn't it? That's a -1. It's the same value. You're plugging in that same value that it's asking you to plug in. That's what I'm doing. I'm taking this right here. It's asking me to plug in a 4 the first time, which I got 24. And the second time I'm plugging in a -1. And I'm taking each of those values and then adding them together, which would then give me a 23. So when it says g of 4 or g of -1, it's asking what is the value of the function g defined at each one of those values. Hold on just one second. Sorry about that, guys. I'm back. Okay, so now, number 14. This one, we're finding the value of h defined at 2. We're finding the value of f defined at -9. And then we're doing a couple of different operations to them. So h defined at 2. So I'm going to simplify before I multiply. And that's going to give me a -5 minus 1. So that's going to be -6. So I've got 3 times -6 and then I'm going to do f. I'm going to find the value of the function f at -9. So I've got 8 minus 3 times -9. So that's 8 plus 27. So that's 35. So now I have 3 times a -6, which is -18, minus 35. So that equals -53. How are you guys doing on these?
Eh.
I don't get that one, Miss Sparks.
Okay. Can you tell me where I lost you, or
Okay, I just
should I just start over?
like for X, I thought it was times.
You thought for which one?
Because for number 14, I thought it was supposed to be like over there, that chart.
And use that.
Okay, so so this right here, the H, right?
Yes.
So when you plugged in -5/2, and then you plugged in a 2 right here, right? Or you could write it 2/1
Mhm.
-1. And so then you simplify before you multiply. So then I would have a -5 here, -1, which would be a -6.
Okay.
So I'm going to plug in -6 right there. So that's 3 times a -6.
Okay.
And then you have to go over and plug in that -9 into the f of x one.
Okay.
Does that make sense?
Yeah, that helps.
Or did I lose you?
No, that's better.
Is it better? Okay, good. It's
You
a lot of
lost me.
times with these on this, I lost you. Okay. All right.
You lost me.
So on this, okay. All right. Thank you. I appreciate y'all being honest. Okay. Okay. So let's look at the equation first at number 14. And I'm going to write kind of in different colors for each section, and maybe that will help. You know what I'm saying? Okay. So the original equation is 3 times whatever the value of h of 2 is. So h is this one right here. So what it's telling me, I have to plug in whatever value I get when I plug in a 2 over here. So that's the first value I have to get. Okay? So I've done that. Did I lose you in getting the value? Is that where I lost you? Should I redo that part? I'm sorry?
Now I get it.
Okay. So then after, Sophia, how about you? Are you with me? Or did
No.
should I keep going? Okay. So should I redo plugging the value in?
Yes, please.
Okay. Okay. All right. So it's telling me to solve this at a value of 2. So this is H right here. So I'm going to plug in 5/2 times 2/1, because I'm just writing it as a fraction. It's still 2. And then -1. Simplify before you multiply. So I've got -5 times 1, which is -5 over 1, which is still just -5, minus 1. So that value is 6, -6. So over here in my equation, I plugged in a -6. Do you get that part?
Yes.
Okay. So then it's asking me to subtract from it. It's asking me to subtract from it the function f at the value of 9. So whatever that value is, whatever the ending value is, after I've plugged in a -9, it's asking me to do that on f of x. So I'm going to say 8 minus 3 times a -9. So that's going to be 8, and then -3 times a -9 is a positive 27. So that gives me a 35. So in this over here, I'm going to plug in 35. So now I have the equation 3 times -6, which is the value of h of 2, minus 35, which is the value of f defined at -9. So following the PEMDAS rule, I have to multiply first. So 3 times a -6 is -18. Make this look more like a 6. That's a -18. I'm going to erase that. Okay. Are y'all with me? Did I lose anybody? Negative 18 minus 35. So that equals negative 53. Was that better?
Yeah, it helped.
There's a lot of side work to, okay. There's a lot of side work to that one. And there's a lot of places, moving parts in that one. So it's just about making sure, like, in all honesty, if I were working this one out, I would have to move it to a different sheet of paper and make sure all my side work was going on. Because I would be writing in each one, like I would be writing in like parentheses, each one of those functions defined at that value. Okay, I'm going to move on to 15. Y'all are asking really good questions and you're working really hard. I'm so proud of you guys. And Kinsley, was that you that asked that question on 14? You started good conversation. I don't know who started that. I'm trying to recognize voices. I'm not always really good. But number 15. Now this one's unusual because you're given the answer. So basically, let's think about this for just a minute. You're given that f of x equals negative 13, but up here it's telling us that f of x equals 8 minus 3. So if you think about it, it's telling us that f of x equals this, but f of x also equals this. And then it's asking us, so find what x is. So if f of x equals this, and it also equals this, then it would stand to reason by mathematical laws that we could actually set negative 13 equal to 8 minus 3x to solve for x. And now it's just a regular algebra problem.
Oh.
So we're going to subtract 8 from both sides. And we got negative 21 equals negative 3x. Then divide both sides by negative 3. And then Miss Sparks runs into the next problem. So you have x equals 7. Same principle on number 16. It's saying that h of x equals 39.
Don't erase it
But
yet.
over here on the left hand.
Don't erase it yet.
Oh, sorry.
No, you're fine. I just need the part that you haven't erased yet.
Oh, okay, good. All right, well, I'll erase this piece then. Can y'all see that okay, even when I write into the next problem? I always feel so bad about that. On number 16, it's telling us that h of x equals 39, but it's also telling us h of x equals negative 5 over 2 x minus 1. So then we can say negative 5 halves x minus 1 equals 39. Because if h of x equals 39 and it also equals negative 5 halves x minus 1, then those two things must be equivalent. So once again, it's just a regular algebra problem. We're going to add 1 to both sides. And that gives us negative 5 halves x equals 40. And now we can multiply by the reciprocal, which is negative 2/5. It's not going to work because I'm going to run out of room over here. So y'all aren't going to be able to see that very good. So I'm going to do this. Negative 5 halves x minus 1 equals 39. So I'm going to add 1. And then I'm going to clear the fraction by multiplying by its reciprocal. I'm going to make that over 1. 5, simplify before you multiply. 8 times negative 2 is negative 16. So x equals negative 16. Are y'all writing that down?
Yes, ma'am. Yes, ma'am.
Does that make sense?
A little bit. A little bit.
A little bit? Is it just the fraction that confuses you? Or is it the principle of setting it up?
It's just plugging it all in. But once I get it all plugged in.
So setting it up? Okay. Does it make sense to you that if two things equal each other, if h of x equals 39, but it also equals negative 5 halves x minus 1, you can get, you got that figured out. Is clearing the fractions still trouble for anybody? Is everybody good with that?
Yes, ma'am.
Yes, ma'am.
Okay. Is there anybody that would like me to go back and do some of the other problems? Or do you just want to check them? Was everybody done writing that one down?
No.
Anybody?
No.
You were not. Okay, sorry about that. There you go.
Could you do some of the homework, please? Unit 3.
Yes, I sure can, Eli. Yes, absolutely. I sure will. I'll be glad to do that. Y'all let me know when everybody's got this written down and I'll switch back over to it.
Did we get like a homework number 4?
That's a great question, Courtney. Thank you so much for bringing that up because it was on the lesson plan. And I'm so glad that you brought that up because yesterday we didn't get through as much as I thought we would get through in class. And so I had hoped that I was going to pass out homework number 4, which has much to do with what we're doing right now, all the function notation applications that we're doing. But we did not get that. So basically what you're doing is completing these problems and homework number 3. I did not hand out homework number 4 as outlined on the lesson plan. So I have updated that. And so homework number 4 will be passed out in class tomorrow. Great question. Thank you for helping me remember to clarify that.
Miss Sparks, could you do number 17 on the
you were only responsible for through 16. I'm doing 17, 18, and 19 in class tomorrow.
Oh, okay.
So does that make you feel better?
Yeah.
How many of you actually watched the Ed puzzle that I posted
I did.
on function
I did.
notation?
I did.
Okay. Was it helpful for you?
Yes.
Yeah.
Yes.
It was?
Yeah.
Okay,
Yes,
good.
ma'am. Yes, ma'am.
Okay. Well, I just thought more examples would definitely help. Okay. Eli, would you just like me to start with number 1?
Yes, please.
Or do you want?
Yes, please.
Okay. I'll be happy to. All right. Because it's going to require a lot of side work, I might need your help getting it transferred over here, because I think I'm going to be better off using a big blank piece. It's not erasing. Oh, I guess we're locked up. It's my favorite. Okay. We got y equals negative 4x plus 3.
Hi, Miss Sparks. Thank you for helping me.
You're welcome. We'll keep working on this tomorrow in class too. Hey, Mary, are you still there? Is she gone? Okay. I believe it was 0, 1, 2, 3. Is that correct? Yeah. Are you still with me, Eli?
Yes, ma'am.
Negative 4
Yes,
times
ma'am.
0 plus 3. So basically what you're going to do is plug in each one of these. So I've got 0 plus 3 and y equals 3. So it's 0, 3. So I'm going to put in a 3. Whoops. And then I've got y equals negative 4 times 1 plus 3. That's negative 4 plus 3. So that's going to be negative 1. So I plug in negative 1 here. Is this making sense?
Yes,
And
ma'am.
then I'm just going to kind of cheat.
Yes, ma'am.
Okay, and go back and use those two and start substituting in there. So I've got 2. So I've got negative 8 plus 3. So that's going to be negative 5. And then I'm going to plug in a 3. So that's going to be negative 12. And negative 12 plus 3 is negative 9. So I've got negative 5, negative 9. So now I'm going to plot them 0, 3. So 0, and then I'm going to go up 3. 1, 2, 3. and then it's 1, -1. And then it's 2, -5. 1, 2, 3, 4, 5. And then -9 would be way off the charts, way down here. So I can't even really get it on there. So I can only graph the first 3 points. And my line is a little squirrely. Okay, does that make sense? Because when you plug in these values into the function, it's actually giving you an ordered pair for the coordinate plane. So 0, or the x was 0, 1, 2, 3. And then once you plug in those values inside the equation, you are figuring what the y coordinate would be. So now we have 4 ordered pairs in our xy table that we can actually plot on the coordinate plane, and it forms a line. Does that make sense?
Yes, ma'am. Yes, ma'am.
Okay, and then on on number 2, I've got, whoops, it's not my eraser. Number 2, I've got a different equation, but I'm still going to be using an XY table. And you will note that there's a fraction in this equation. So because we can pick any x that we want to, we would like to choose x's that are multiples of the denominator so that it will make working with the fraction simpler. So the denominator in this case is 3. So you'll note that in the xy table, -6, -3, 0, which that's, multiple of every number really. And then because 0 times any number is always 0, and then 3. So multiples of 3 were chosen in order to simplify actually finding the y value in this. And that's what you would always do when you're working with a fraction. So the equation is 2/3 x minus 1. And the values are -6, -3, 0, and 3. So we'll plug in 2/3 times -6 minus 1. So we're going to this is like 6/1. Let me write that so that's not, because when I write it, it looks a little clearer if we're writing it as 6/1 when we're dealing with the fractions. And -6/1 is the exact same thing as -6. So we're going to simplify before we multiply. So 2 times -2 is -4/1, which is still -4, minus 1. So that's -5. So the y value is -5 for the -6. And then I've got y equals 2/3 x, or -3 minus 5. Simplify before you multiply. So that's 2 times -1. That's -2 minus 5. Oh, I'm sorry. I messed that up. It's not minus 5. I was like, what am I took the answer. It's -1 here. My apologies. I wrote the problem down wrong. I got mixed up I was reading my -5 answer as part of the problem. So that's -3. So I've got 2 points now. I'm going to go back over and fill those in. -5, -3. Now I'm going to plug in a 0. And 0 times anything is 0. So that's -1. And now I'm going to plug in a +3. Simplify before you multiply. So now I've got 2 additional points. I've got -1 and 1. So I'm going to plot those. I'm going to -6. 1, 2, 3, 4, 5, 6. And then down 1, 2, 3, 4, 5. And then -3, -3. 1, 2, 3. 1, 2, 3. And then 0, -1. 0, negative. Oops, my bad. 0, -1. And then 3, 1. 1, 2, 3. And then for number 3, I've got y equals 2x. And my values doesn't really matter too much on this one because I don't have a fraction to work with. So I can choose any values. And a lot of times I like to choose the ones that I can do quick math with, and as did the person who created these worksheets. So they just picked -1, 0, 1, and 2. So pretty simple values to work with when plugging in. So y equals 2 times -1. That's going to be -2. Y equals 2 times 0. So that's going to be y equals 0. And then I've got y equals 2 times 1, which is going to be 2. And then y, when x equals 2, y would equal 4. So basically what you're doing is just taking any of your x values and plugging those x values into where the x is in the equation and then solving for the y. And then that gives you an ordered pair. And then you graph the ordered pair. And then that ordered pair then when you connect the dots, it creates a line. So over 1, down 2. 0, 0, that's the origin. And right 1, up 2. Right 2, up 4. Connect them. And you have your line. Now on number 4, once again, we're dealing with a fraction. So we want to choose x values that are multiples of 2, which are in the denominator, because that makes working with our equations much easier. So we've got y equals 5 minus 1/2 x. And once again, we want to choose those x values that makes working with the fraction easier. So we're going to pick multiples of 2, which that 2 is the denominator. So we're going to pick -2, 0, which 0 works with anything, 2, and 4. And 0 makes life really easy. So we've got 5 minus 1/2 times negative 2 over 1, because I'm going to state it as a fraction. Simplify before you multiply. So I've got 1 times negative 1. So that's going to be negative 1. So we have y equals 5 minus a minus 1, which is the same as 5 plus 1, which is 6. And then y equals 5 minus 1/2 times 0, which that's 5 minus 0, which that's 5. So I have 5 minus 1/2 times 2. 5 minus, simplify before you multiply, 1. And that's going to be 4. And then we have y equals 5 minus 1/2 times 4 over 1, which is the same as 4. Just stating it as a fraction so it makes it easier. Simplify before you multiply. 1 times 2 is 2. 5 minus 2 is 3. So I have the coordinates negative 2, 6, 0, 5, 2, 4, 4, 3. So I'll go left 2 and down 6. 1, 2, 3, 4, 5, 6. 0, 5. So I'll be at the origin for the x-axis, and I'll drop down to 5. I'll go over to 2, right 2, down 4, right 4, down 3. Oh, I was supposed to go up. My bad. Got to watch yourself. So right 2, up 6. 0, 5. 2, 4. And then 4, 3. Better. Okay. Find the range of the function y equals 7x minus 1 when the domain is -1, 0, and 1. So once again, just like the tables, you're going to write in y equals, and then you're going to plug in 7 times -1 minus 1. That's -7 minus 1. That's -8. So my range is going to equal -8. And I'm going to plug in 0. That's going to be 0 minus 1. So, and that's minus 1. And then we're going to plug in 1. That's going to be 7 minus 1. That's 6. So my range is kind of wonky looking for this one now. I'll erase this, but it's -8, 1, and 6. Because the range is just the values after you've plugged in the domain. It's all of the values that you find for that. So -8, -1, and 6. Number 6 is the same way. You've got 1/2 x plus 3. And fortunately, the domain are all numbers. that are multiples of 2 for the denominator. So we would just plug in each one of those values to find our range. So y equals 1/2 times -2 plus 3. Simplify before you multiply. So that's going to be 2. I'm going to write my numbers over here so I can keep track of them, and then I'll rewrite them as the set when I'm done. Because you also, one of the other things, it worked out good for me on number 5, but you typically, when you're stating a domain and range, you want them to be in ascending order, meaning going from least to greatest, and you don't want to put repeats in there. I just want to drive that point home. Wasn't very strict about it on the quiz 1, but going forward, we really need to do that. Y equals 1/2 times 0, which is the second value in the domain. 0 plus 3, so that's 3. The next value in the domain is a positive 2. So you'll plug in a positive 2 for x. Simplify before you multiply. That's going to give me a 4. The fourth and final value in this particular domain is 4. Simplify before you multiply. 2 times 1 is 2. So that's 5. So our range is going to be the set of numbers. Get this erased. Pretty bracket. They're in ascending order and there's no repeats. So the range, the domain is -2, 0, 2, 4, and the range is 2, 3, 4, and 5. So the domain is the x's and the range is the y's. For number 7, 8, 9, and 10, you're supposed to match the function to the table of values. So what I would do in looking at this, number 8 is the easiest one that you could kind of work with in your head, really. So I would kind of start with 8. That's what I would do if I was doing this, to kind of work through and figure out which one goes where. It's the simplest because you're only subtracting 7 from a value. So I just would say 8, and then I would start with A. So if I plugged in a -3 for this x, would I get a -10? In fact, I would. Okay, well, that one checks, but just to be on the safe side, I better check -1. So if I plugged in a -1 here, would I get a -8? Yes, I would. So I'm going to venture to say that I'm probably on the right track, but you could go ahead and check them all. If you did a 2 in there, you would actually get a -5. And if you did a 6, you would get a -1. So you've got A. So that rules that one out for the rest of them. And given the fact that I have suggested and she has followed suit, what multiples would you use as your x for number 7? What would the x's be? They would be multiples of what?
Maybe.
Because you want to simplify this. So you would have multiples of the denominator for number 7. So what's the denominator in number 7?
3.
Yes. So I'm going to look at all, like A isn't a possibility anymore. So I'm going to look at the X values for B, C, and D and see which ones have multiples of 3. Which one of B, C, and D have multiples of 3 as the X value? Is it B, C, or D? What are the multiples of 3?
6.
Uh-huh. What are some other ones? What's 3
9.
times 3?
9.
What's 3 times 4?
12.
One of these 3 have multiples of 3. B, C, or D in the X column. So you're only looking at X. C. Good job. So let's just plug in -3. So 2/3 times -3 plus 4. So simplify before you multiply. So 2 times -1 is -2 plus 4 would give me a 2. And so that checks. So I'm going to venture to say that that's probably, and if I plugged in a 0 up there, I would get a 4 because that would cancel this out. So number 7 is C. Is my reasoning, does it make sense to you?
Yes, ma'am. Yes, ma'am.
Multiple choice, you kind of want to use some of the reasoning skills to eliminate possibilities. Okay? So C would be number 7. So now we just have to match B and D. And so a really cool thing, you wouldn't opt for this, but personally, if it were me, what I would do is opt for the one with the fraction, because I know that I'm going to pick for my X values multiples of the denominator. What's the denominator in number 9?
2.
2. So what are some multiples of 2?
4, 6.
Yeah, good job. So which one between B and D have the multiples of 2 in the X value row?
D.
Yeah, good job. So 9 is D. Awesome. And then your only one left is B to go with 10. And you could go back and check your values, but it'll work. So basically what we did on this was kind of use some of our reasoning strategies based on some things that we did before. We plugged in some values just to double check our reasoning. But that kind of helped on that one. That's how I would approach a matching situation with regard to this. Does that make sense?
Yes, ma'am.
Okay. Did that help you?
Yes, ma'am.
Okay, good. Any other questions?
No, ma'am.
Okay. I think that was all the worksheets, right?
Yes, ma'am.
Okay, you feel caught up
Yes, ma'am.
and prepared for tomorrow? Thank you so much for working so hard and coming to Math Lab.
Thank you.
You have a blessed afternoon.
You too.